In this demonstration, I'll show you how to evaluate limits using algebra and the limit laws. This is part 2 of our limit series. In question number 1, they ask, what is the limit as x approaches 0 from the left, that superscript denotes coming from the left, when you have 6 over 1 plus 2 to the power of 1 over x. So as we approach 0 from the left side, obviously we're coming from the negatives and we're making our way to 0. So let's pretend that our x value is negative 0.000001, an arbitrarily really small non-zero value. And let's pretend that we took 1 and we placed this number in here, 1 divided by negative 0.000001, and we ended up with the number negative 1 million. And subsequently, we took 2 to the power of negative 1 million. What would we get? We would end up with 2 to the power of the answer that we just got. We got 0. So as x approaches 0 from the left side, this ends up becoming 0. So we are left with 6 over 1 plus 0. Therefore, our limit is equal to 6 over 1, which is equal to 6. In question number 2, they want us to find the limit as x approaches infinity for this expression. Now, of course, if we had a graph representing this function, it would be a lot easier to figure out what's going on. But we don't have that luxury, so what we have to do is use some prior knowledge to figure this one out. The first thing that I would do if I see a question like this, especially one with radicals, is I would try to multiply the number by its conjugate. So what I'm going to do is I'm going to multiply the top and the bottom by the conjugate of this. The square root of x squared plus 2x plus, and what you do to the top, you must do to the bottom. So we're going to repeat this underneath. X squared plus 2x plus the square root of x squared plus 3x. So we're going to multiply this all out. X squared plus 2x. Remember, since this and this are the same term, multiplying them out destroys the square root. And then plus this times this, which is equal to x squared plus 2x and x squared plus 3x. And lastly, these two multiplied give us the square root of x squared plus 3x times x squared plus 2x. Multiplying this one with this one gives us essentially the number without the square root minus x squared plus 3x. And don't forget the brackets around these two terms. You'll notice that these two middle terms are the exact same. I'm just going to highlight them to show you. So that suggests we can simply cancel them out. And we end up with, remember this is just the numerators, I haven't written the denominators. For the numerators and the denominators together, we get x squared plus 2x minus x squared plus 3x. And at the bottom, we end up with this. Let's further simplify the top part. You'll notice that if we multiply this negative out, this term and this term will cancel out, leaving us with, at the top, 2x minus 3x, which ends up becoming negative x. So we are left with, I'm going to increase the space here, negative x over this complicated bottom part. Interestingly, if we were to take the limit right now, we would still end up with an undesirable value. So what we could do is use a little trick. And the trick involves dividing both the top and the bottom by the square root of x squared. And what this will do is it will inject a value into the bottoms, which will help us simplify the bottom part. So let me demonstrate. I'm going to divide by the square root of x to the power of 2. And I'm going to do that to the bottom here. Divide this by the square root of x to the power of 2, and this one by the x to the power of 2. And at the top, remember that the square root of x to the power of 2 is equal to x. So at the top we end up with negative x over x is equal to negative 1. And at the bottom, since we are dividing a square root by a square root, we can house it under one square root. So we end up with square root of x squared plus 2x over x squared, and the square root of x squared plus 3x over x squared. Now, of course, this would distribute to this term and to this term, and this would distribute to this term and to that term. What we end up with is the square root of 1 plus 2 over x. That's this term. That's what this simplifies to. And this simplifies to the square root of 1 plus 3 over x. So putting this all together, we end up with negative 1 over 1 plus 2x plus the square root of 1 plus 3x. And remember, we're taking the limit as x approaches infinity. Now, if we were to put an infinitely large number here, we would end up with 0. Think about it. 2 divided by a billion is pretty much equal to 0. And similarly, you get the same effect here. So negative 1 over the square root of 1 plus the square root of 1 is 2. So as x approaches infinity, the limit of this function is negative 1 over 2. Let's move on to question number 3. In question number 3, we have an absolute, and the first time we approached a situation with an absolute was in part 1 of this series. And what you do is remember that this is the same thing as negative x minus 3. So what you have to do is you have to take the limit of x minus 3 as a denominator and negative x minus 3. And if they are the same, then the limit is the number that you end up with. And if they are different, the limit does not exist. So let me show you what I mean. Let's start with, first of all, factoring the top part, because it's totally factorable. What two numbers multiply to 15 and add to 2? The correct numbers are 5 and negative 3. So we can factor this, and I do have a video on factoring in case you don't know how to do this. X plus 5 and x minus 3 over x minus 3. Remember, I'm using this variant right now. And what this does is it cancels out the top and the bottom, leaving us only with this, and we can apply the limit and we get 8, positive 8. And we'll do the same thing for this variant. So once again, x plus 5 times x minus 3 over negative x minus 3. These two cancel out, and we are left with negative x plus 5 gives us negative 3 plus 5, which gives us negative 8. Now, since this limit and this limit are not the same, limit does not exist. So there you have it. Those are 3 more challenging limit problems that you can add to your arsenal when it comes to solving limits without graphs. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.